Well, howdy there, internet people. Wait, that's that's not how I do my intros. I think that's actually someone else's. Huh. So I got asked a question by one of my friends, and in typical fashion for said friend, they told me that they weren't going to take the time to read out the answer that I gave to them. So here we go. It's now in video format. But before I get into the question and the answer, I need to give you guys, the viewers, a little bit of context. I currently live in Hell's Dumpster Fire, also known as Texas, and I spent a little bit of time in Hell's Flooded Dumpster Fire, Florida. When people ask why it's so hot in those places, it's usually a facetious question because they already know the answer. The abomination that is the United States southern coastline is just naturally hot. But over the last few decades, that question has become less of a complaint about why is it so hot and more of a why is it hotter than it normally is? So, let's talk about the weather, climate, and why it's changing. Just as a quick aside before we actually get into the video here, if you happen to see my camera moving around, zooming in, autofocusing, a whole bunch of other things, it's because I'm finally starting to use the camera for what it's supposed to be able to do. Not just as something that's completely stationary. So, for example, if I went and I did this number, you know, it's going to follow me around just a little bit. And that's going to be somewhat normal throughout the video, just as a heads up. Let's start with the basics here. Weather and climate are not the same thing. While they are related terms, using them interchangeably is kind of like using rugby and football interchangeably. They both use the same ball, but they're clearly not the same game. Weather is the atmospheric state at a specific place at a specific time, while climate is the prevailing weather conditions of an area over a long period of time. So while the weather may change from minute to minute, the climate largely remains the same and requires significant changes to the environment and atmospheric patterns of a region to be altered in any meaningful way. Now, I could just answer the question of why is it getting hotter than it normally is with three little words: anthropogenic climate change. But just saying those words is probably going to be unsatisfactory to a lot of people. And let's face it, the concept is hard to understand without knowing the factors and processes that control it to begin with. Now, there is a lot of them that exist, so I'm going to simplify it down to roughly four-ish categories that should be easy to understand. It's two that we can't really see or affect, and two that we can. Those are the sun, the earth, the environment, and the atmospheric patterns. If you're trying to guess as to which one is which, I'm going to make this entire thing simple for you. It's the sun and the earth that we can't really do much about. So what do I mean by the sun and the earth being factors for natural climate change? Well, for the sun, it's pretty simple to explain. The massive ball of nuclear fusion fire that our planet orbits around sends a massive amount of heat towards our planet in the form of light. The natural cycles of intensity that it goes through, as well as the sunspots and solar flares that it sends out, are all things that are out of our control. But they affect our planet's overall temperature in a significant way. It's just going to keep on sending out plenty of light and heat for the next 4 billion years, and it will be doing it at basically the same rate it has been up until it blows up and it's no longer our problem. With the Earth, it's similarly large scale natural processes that affect our climate. Things like rotation speed, planetary precession, and the position within the Earth's orbit. These all have relatively simple ways in how they alter the climate of the planet. Rotation speed affects just how fast the atmosphere cycles around the planet, but since it's fairly stable, it doesn't change a whole lot. Precession is the natural wobble of the planet around its rotational axis that 23-ish degree tilt that the planet has wobbles back and forth slowly, changing which hemisphere of the planet faces the sun more prominently and making it warmer either in the northern or southern hemisphere. And because the orbit of the planet is oblong, it puts the planet closer or further away from the sun as the year progresses. You'll understand that that last one is just the seasons. Those are the factors that we can't do anything about. And it's probably a good thing that we can't, because they're also the most stable factors affecting our climate. We don't really end up seeing significant major changes to them within a single lifetime, let alone a civilization. Like, the precession cycle of the planet is over 25,000 years. You're just not going to see the effects of it, to be honest. But the environment and atmospheric patterns, those are different because we can change them, and quite quickly too. We tend to think of our environment as unchanging, and that couldn't be further from the truth. I want you to think about just how quickly roads and housing developments go into place. If you don't think that those affect our climate, you're not just wrong, you're very wrong. Just as an example, what was Mexico City before it became Mexico City? It was a lake, Lake Texcoco. I mean, technically it was like a series of 5-ish lakes that all, flooded back and forth together to become one big lake, and then, shrank back down to become, the 5 lakes again. And that's aside the point, okay? Now, if you've ever been to Mexico City recently, you'll know that there's not a big lake there. In fact, about the best you're going to find is 2 small ones. There, one's up in the top right corner, one in the bottom left, I think is what it is. Maybe it's just a little further south. I haven't been there, so I can't tell you exactly. I've only looked at maps, and it's been a minute. Anyways, you could probably imagine that you'll have some significant environmental changes when you remove an entire lake from an ecosystem, especially one the size of Lake Texcoco. It's roughly half the size of Lake Ontario. If you haven't seen that, that's a big lake. Changes to the environment have drastic effects on the climate of a region, regardless of how quickly they occur. Rivers will naturally meander through an area over the course of many years, creating new floodplains or changing what was once a fertile wetland into a dry and arid desert. We can actually see the evidence of that one in the Middle East, where the ruins that made up ancient Mesopotamian civilizations that once sat on the edges of the Tigris and Euphrates rivers now sit miles away from them in the barren desert. What we're talking about here is the natural process of climate change in localized environments. The desertification of northern Africa, the rising of the Himalayas, the expansion of the Rift Valley. All natural things that change localized environments and have an impact on their climates. There's some unnatural things that we'll get into in a few minutes, but I still have the last category to talk about. The atmospheric patterns of the planet are largely side effects of some of the other factors we've already talked about. The spin of the planet causes the Coriolis effect, the precession affects the jet stream, and the direct energy from the sun causes the rain cycles and makes just about every weather phenomenon on the planet possible. You also have things like the changing of environments that actually affects how those particular weather patterns can form in a certain region, or how they would affect multiple regions as they come across them. I mean, storms normally actually end up stopping once they hit into a mountain face, or they will form on the opposite side of a mountain face and leave another area to where it is more arid in the first place. It's part of that desertification process. Anyways, as you can kind of assume from what has an effect on it, atmospheric patterns are involved in global climate. It's one of 2 systems on the planet that actually do affect it globally. The other being oceanic currents, which have a very similar function. In fact, because the 2 are so similar, I mean, like, even the things that would affect them directly are basically the same. I'm going to talk about them together. Allow me a moment to explain currents to you real quick. For both atmospheric and oceanic currents, it's temperature differences that drive them. You've heard the saying that as warm air rises, cold air sinks. Well, that's the basic principle here. Liquids flow from a place of higher temperature to cooler temperature and vice versa. With the vertical currents in both the atmosphere and the ocean, it's, in the case of the atmosphere, the colder air closer towards space sinks down and gets replaced by the warmer air rising up closer towards the surface. And with the oceans, it's the colder water that is closer to the bottom of the ocean that floats up and is replaced by the warmer water closer to the surface. It also does the same thing towards the poles. At the poles, it's going to be colder water, so it's going to flow south or north, depending on which part of the world you're in, towards the equator. And then the warmer water that is there is going to flow in the opposite direction. Same with the air. It's going to go from the poles down towards the equator and vice versa. The currents of the atmosphere and the ocean are global climate systems. The vertical currents of the atmosphere create our weather phenomenon such as rain, snow, and hail, while the polar oceanic currents serve to regulate the temperature of the planet. The storms that form off the coast of Africa are blown into the Atlantic Ocean and carried over to the Americas by the northern equatorial current. And if you haven't guessed, that's where the hurricanes come from, all from over there. As a global system, takes them and carries them off. And with the oceanic currents, the warm waters around the Caribbean are brought north to not only bring nutrients to the North Atlantic to create rich fishing grounds, but it also helps regulate the water temperatures within the areas of the Northern Atlantic, keeping places like Northern Europe from being a complete and frozen wasteland. As you can imagine, a disturbance in either of these two has global ramifications. A good example of this is the year of 1816, also known as the year without a summer, or 1800 and froze to death. It was caused by the eruption of Mount Tambora, located in Indonesia, in 1815. The volcanic ash from the eruption was scattered into the stratosphere and created a cloud roughly the size of Australia that was spread across the whole planet by the atmospheric currents. This reduced global temperature somewhere between 2 and 7 degrees, freezing out crops, creating unexpected torrential rains, and raising cases of disease outbreaks. Over 100,000 people lost their lives due to climate change caused by a single volcanic eruption, an event that we didn't really have any control over and was only a temporary change that lasted for one summer. So imagine if that change was permanent. Volcanic eruptions are responsible for one of the largest... Oh, no. My notes say it's not one of. It is the largest mass extinction event on the planet. The Permian-Triassic extinction event, which I'm not actually sure if I've talked about before on the channel, which is weird, is also known as the Great Dying. The leading theory is that it was caused by volcanic activity in what is now Siberia, and it led to a loss of 96% of all marine species and 70% of all terrestrial species. Reason this happened was that it changed the global temperatures to an average of somewhere between 35 and 40 degrees Celsius. That's not the actual differential number. That is the total that it came out to, which is roughly somewhere in the ballpark of, let's see, some quick math, which is roughly somewhere in the ballpark of 95 to 104 degrees Fahrenheit every day. This is the difference between a temporary change like the Tambora eruption and a permanent change like the end Permian extinction. The scale is exponentially different. Anthropogenic climate change shares more in common with the 5 large mass extinction events than it does with the natural cycle of changing climate within the Earth's history, which is why it's probably more accurate to call it the anthropogenic mass extinction event in the long run. But that's probably not something you're going to care about if we're being honest. Most people don't care about things outside of how it directly affects them. So let's get into how it's going to hit you. And I'm not going to sugarcoat it. It's a lot worse than you're probably thinking. Now, to explain how it's going to hit you, I'm going to have to explain how it's happening to begin with. If you've noticed, I've only been talking about how climate change naturally happens on the planet. But there have been bits and hints that have trickled in that could lead you to connect the dots. If you caught them, turn up the heat on that subscribe button. That's the only kind of climate change that is acceptable on this channel. You know, for some reason, that joke just... I don't think that one hits quite the way that I was expecting it to. Environmental and atmospheric changes are the only things that we really need to concern ourselves with here. The mention of construction for roads and cities earlier wasn't just for a relatable example. These are physical ways that we have altered the environment. Sure, there's a number of animals that make large changes to the environment, like, you know, beavers, but in terms of sheer quantity and size of area that can be affected, there is no animal that has a greater effect on their environment than humans do. So roads do this interesting thing that I'm sure you've noticed. They retain heat, and a lot of it. They're basically giant slabs of rock on the ground, and if you've ever left a rock out in the sun and then you've come back along and tried to move it a little later, you'll know that they're extremely hot, and they stay that way for a long period of time. And introducing a structure that soaks up heat into an environment is going to increase the natural amount of heat retained within it overnight. This increased amount of heat within an environment can actually cause the ground to dry out and make it retain heat better. So we're actively making our environments hotter by pure accident, just by introducing roads and cities made of concrete. We also do things like clearing forests and diverting rivers to create housing developments, farmlands, and to harvest a variety of natural resources. It's not so much that we do these things that's the problem, but rather the scale at which we do them and the lack of consideration for impact on the natural environment that causes issues. With the exceptions of something like a volcanic eruption or the earthquakes in California, a good majority of the natural disasters that we've experienced are direct results of our alterations of the natural environment. Which, if I haven't made it clear enough, is climate change. It's just localized climate change rather than on a global scale. Oddly enough, if most of what we did to our local environments happened naturally, it would be viewed as a form of desertification. You know, like that thing that's going on in Northern Africa and has been for probably the past 10,000-ish years or so. You know, there's a reason why North Africa, for the longest period of time, was actually the home of large, massive civilizations. Like, you know, the city of Timbuktu is now in the desert, but when it was made, it was on the edge of a forest. And just to keep on pace with all of this, those natural disasters that I'm talking about, there are things like the earthquakes that are occurring currently in Texas. I mean, well, you know, not right now as I'm filming it, but, you know, the ones that have been occurring over the past several years that haven't, they're direct results of fracking, and we can show that. All right. You also have things like the mass flooding that occurs all throughout the nation. There's very clear examples of our own erosion that has occurred that leads to these flooding events. Or, you know, the forest fires in California and Hawaii. You know, those two. The thing with our self-induced desertification is that, for the most part, it's reversible. And we have ways to minimize the impact of what we do in the future. Sure, something like strip mining might be a bit difficult to reverse or minimize the impact of, but we can do it. Then again, if there's a strip mine in your backyard, you've probably got a whole host of other problems to deal with in addition to the environmental impacts of it. Anyways, something as simple as planting trees can help reverse the environmental impacts. In fact, it's been proposed a number of times to help combat the desertification of the Sahara. The shade reduces the heat that reaches the ground, and the roots help the ground to retain water. But the reversible issues that we have aren't the ones that are causing the most problems. Our atmosphere is made up of gases, primarily nitrogen and oxygen. Now, hold on there. You might be thinking to yourself, didn't he say that he was going to talk about how climate change is going to affect me? What does our atmosphere and what it's made of have to do with me? Well, slow down there. I'm still in the explaining phase of everything and how this is all happening, so that you'll understand the impacts when we get to them. Yes, the entire last page of my script was to explain desertification. Now, where were we? Right, the atmosphere. The exact chemical composition of the atmosphere tends to fluctuate within a few percentage points, but in general it goes like this. 78% nitrogen, 21% oxygen, 0.9% argon, and 0.1% various other gases, including carbon dioxide, water vapor, and neon. You'll notice that carbon makes up a percentage of our atmosphere. As you can imagine, having more of it in the atmosphere is going to do something to alter the world. Just as a quick reminder, when fossil fuels are burned, it releases carbon dioxide and carbon monoxide into the atmosphere. Just about every gas that contains carbon in it is what is known as a greenhouse gas. They have the ability to trap and retain heat, much like a greenhouse does. And if it hasn't become abundantly clear so far, heat is the major driving factor in our climate change, be that a reduction or an increase in it. For the Tambora eruption, it created a volcanic winter by blocking out the sun with volcanic ash. And with the Permian extinction, it was the release of an abundance of greenhouse gases, including carbon dioxide and methane, that created a global rise in temperature. Anything that can alter global temperatures, even by something as small as 1 to 2 degrees, has massive ramifications on the climate. It's a matter of exponential change. 2 degrees colder and regions that once produced much of the food for a country will sustain massive crop failures. And 2 degrees warmer will see a rapid expansion of desertification, even in places where it was being maintained enough to keep it at bay. Remember, I said that the Tambora eruption changed global temperatures temporarily by somewhere between 2 and 7 degrees. A change like that in a specific region is just the weather. But on a global scale, it's a problem. Most global changes in temperature occur over long periods of time and are attributed to things like changes in the precession of the planet or the distance of the planet's orbit. And we occasionally get oddball scenarios like the Tambora eruption. Even the Permian extinction was considered a long-scale event because it took place over thousands of years. Although it was short on a geological scale, that's still a huge amount of time for us. But the current changes in atmospheric carbon have occurred over the past 200 years, ever since the Industrial Revolution. Saying that these things have happened naturally or that the climate always changes shows a blatant disregard for how the processes actually occur and the sheer amount of time that they take to show any real change. Just as a fun fact and easy way to show how long these processes take, when was the last ice age? 10,000 years ago? 20,000 years ago? Both of those answers are wrong. It's right now. There hasn't been a single moment in human history that wasn't in the current ice age. The last glacial maximum was 20,000 years ago, but the ice age hasn't ended yet. Granted, that's very likely to change if we don't find a solution to global climate change. So, now that we have a fairly vague understanding of how it works, we can get into the effects it's going to have on you. First and foremost, places are going to become uninhabitable. If you live in a part of the world that has a remotely arid environment, like, Arizona, Western Texas, most of Africa, the Middle East, etc., etc. That place is going to become a place you can't live. As the world gets warmer, it's going to exacerbate desertification, which means you're going to see less water availability in these places. Rainfall may increase, but the land's ability to retain water is going to disappear. And we're already starting to see things like this happen. Water shortages are commonplace now in many of the areas I just mentioned. I mean, I live in Texas. Houston literally just put out, I think it was last week, a water shortage plan that they have, and they're enforcing it with jail time and fines. Arizona, for all that it is, why would you live there? You know what? I'm not going to judge my friend's opinion on things, but Arizona, as it stands, is undergoing one of the largest massive water shortages that it's ever had. Lake Mead is drying up. All that water flows into Arizona, California. We're already starting to see these things. If these areas become uninhabitable, what's going to happen to the people that live there currently? They're going to move, assuming that they have the ability to in the first place. Additionally, as it gets hotter, ice is going to melt away. Go figure, right? The more water that gets added into the oceans, the higher its level. So if you live on the coastline, your house is likely to get swallowed up by the oceans, and the only person left to potentially buy where you once lived is going to be Aquaman. But more problems arise from the fresh water entering into the ocean. It lowers the ocean's salinity, which affects the way the currents work. The current models just for the Gulf currents show that it will stop completely. And do you remember how that affects Europe and the fisheries off the coast of North America? That's even less places for people to live and less food for people to eat. And just to go one step further, the Great Dust Bowl of the 1930s was caused by extended drought, unusually high temperatures, and poor agricultural practices, which all came together to create massive amounts of wind erosion of the soils. Well, we're already looking at 2 out of 3 for those conditions with the effects of climate change, which is enough to make it a repeat. So the part of America which is largely responsible for food production is an environmental disaster. And you'd see the same effects in just about every breadbasket of the world. Like, the first one that comes to mind outside of America is Ukraine. Although they've got other issues. All of this comes together to create huge influxes of people into the parts of the world least affected. Massive increases in food prices due to its low availability, and less patience from everyone involved. And none of this is even talking about the increases in severe weather events like hurricanes, tornadoes, flash flooding, and heat waves that all come about as direct results of desertification and the water cycle being put into overdrive from the increased heat. All of this comes from the most optimistic looks at an average global temperature increase of 2 to 5 degrees. Worst case scenario has the world repeating the Permian extinction. And it wasn't called the Great Dying for nothing. Climate change isn't something that we can just shrug off. Most of the stuff that I talked about as a hypothetical, this is what will happen, isn't hypothetical. We're already starting to see those things play out. The problem is that what's causing the biggest change to global climate, the rapid increase in carbon-based greenhouse gases, isn't something that we can easily reverse. Once you let the genie out of the bottle, it's really hard to get them back in. There have been some novel approaches, but they don't really work on a large enough scale to slow down the pace of global temperature increase. We're already at 1.5 degree change from what our global average temperature was. We're going to hit 2 degrees really, really soon. So yeah, I skimmed over quite a bit for the sake of making this video understandable to most people. There's a number of technical things about how carbon emissions affect stuff like water quality, erosion, growth rates of microorganisms that feed entire food chains, and a whole host of other things that are detrimental to the world as a whole. But They aren't primary effects of climate change. And I don't think that anyone has the time to dedicate to any of that, let alone debunking the counter arguments people give to climate change. I am going to talk about one of them, however, because it's relevant to the talk about carbon. There are some people out there who make the argument that increased CO2 in the atmosphere is good for plant growth. And to an extent, they're right. Increased amounts of carbon dioxide increases the rate at which a plant grows, assuming that all the other conditions remain the same. Those other conditions are things like soil quality, water availability, and optimal growing temperatures. And if any of those are ringing a bell for you, it's because they're what we've been talking about this entire time. Increased carbon in the atmosphere raises the temperature of the planet, causing prolonged droughts, rapid desertification, erosion of soil quality, and higher overall temperatures. All of which makes it harder and harder for the plants to survive. So the argument doesn't hold any water, which I hear is pretty important to, plant growth. And that's how a lot of people who try to deny climate change or its extent go about it. They cherry pick one piece of data that they think supports their position, but it usually is just so hyper specific or reliant on all other global conditions remaining the same that it either doesn't apply or it serves to disprove their position when looked at in conjunction with other data. It's a problem. It's a huge problem. Like, I don't know how many times I'm going to have to hit the button on this. Like, sure, climate change is not an easy topic to understand. It never has been, it never will be. A lot of the effects and ramifications that we can see from it, well, they take maybe a year or two to actually start coming into effect. And by the time that rolls around, most humans, they're going to, pattern search in the way that our brains are designed to do. And they're not going to actually directly connect those to the root cause that is climate change. They're going to say, oh, well, it's because this country didn't properly manage their water, or, oh, it's because, California is increasing the amount of people that are there. So, they're just taking too much water from us, or, it's a, take your pick, honestly. At the end of the day, everything boils down to climate change in terms of all the problems that we are currently facing in the world. I mean, like Russia invading Ukraine, right? That's a problem. Problem that is largely exacerbated by climate change because majority of their land isn't arable in the first place, and it's getting worse and worse as the climate change goes. You son of... At the end of the day, this is a topic that is difficult to understand for a lot of people, but it's one that we need to understand, if I haven't made it clear enough to you. But just about every example that I've given comes from a historical context, be that the Permian extinction, the Tambora eruption, the Great Dust Bowl. All of those are examples of climate change that we have well-documented information about and how they happened. Using them as examples here should be enough to at least show you the problems and dangers that are going to occur with climate change. And if they haven't, honestly, I don't know why you watched this far into the video. Sure, I could probably do a better job at explaining things here and there. I really could. I try to write out my scripts as best as possible to make them understandable to the average person. At least I try. I think I do. But if I can't get this one across to you with, actually showing, or, well, not showing, I'm telling. I am telling how these processes work and how they culminate into what they do. Yeah, I'm going to be at a loss for words at that point. But hopefully this video did at least a little bit to help you understand that. Right? Yeah. So the TLDR of all this entire video is that it's hotter because climate change. There you go. Thank you. End of movie. There we go. That's it. That's the video. Now I just need to make sure that all my friends see this and wait. What are they talking about now? Space lasers? Oh, God